Hello, Math 10, Mr. Beeland here with your next lesson for today. We are talking still about systems of equations and how to solve them. In particular, we're looking at algebraically solving them. Last time we were looking at the substitution method. This time we're going to be looking at something called the elimination method. Okay, so again, this is still a method for solving these equations or for solving systems. This time you are adding and subtracting to eliminate variables. Remember, we're always just trying to get rid of one of the variables in order to solve the other. Remember, we were solving for y and then replacing it and then finding an actual number for x before. But we can kind of cut some steps out by using the elimination method. Okay, so again, I'll go through the steps and then I'll show some examples here. So first, make sure the equations are lined up. So you just want it so that we're looking here, right? The y and the y, the x and the x, the constant with the constant, right? Make sure they're all lined up. And then what you're going to do is you're going to add or subtract the equation to eliminate the common coefficients. You are then going to solve for the remaining variable, and then just like in before, once you found one of the numbers, then you substitute it back in and solve for the other. Okay, so what does this look like, right? So I've got y equals 3x plus 4, and I've got y equals x minus 2. So what I'm going to do is I'm going to take this equation, and I'm going to subtract it by this equation, okay? So I'm going to basically put brackets around this whole thing, and I'm going to be subtracting that, okay? So y minus y is 0. 3x minus x is 2x. And 4 minus negative 2, that's a double negative, so we're going to end up with plus 6. Okay, well now this looks like a pretty easy question, right? So we just move the 6 over to the other side, and we get 6 equals 2x, so then x equals 3. Okay, so I'll just put that over, oh, sorry, I'm way down here. There we go. I'll put that over here, so 3, and then we just take that 3 and we just punch it back into the top one. Or we punch it into this one here, probably easier. So we punch that in and we get 3 minus 2. Sorry, this should be a negative. Sorry. Negative 3 minus 2. So y equals negative 3 minus 2, which equals negative 5. And again, you can plug these in to the other equation just to make sure, right? So we could plug this in just to make sure that it does equal, right? Negative 5. Let's see if this adds up. 3, negative 3 plus 4. That would be negative 9. Negative 9 plus 4, which, yeah, equals negative 5. So it does line up that way. Great. Okay, let's go through a couple more here. So again, we want to make sure the x's are lined up good, the y's are lined up good, the constants are lined up good. We're going to just pick the one where they are basically identical, right? So x and x. We're not going to try and get rid of the y's. That's not a problem. And again, we are going to subtract the bottom one. So x minus x is 0. 4 minus negative 1, you have positive 5y. And then 13 minus 3. 10, so then y should equal 2. And I'll put my brackets over here, 2. Take that 2, plug it back in, I'll plug it into the top one. X plus 4 times 2 equals 13, so x plus 8 equals 13. Subtract 8 from both sides, you should get x equals 5. There we go. Okay, let's do one more here. We're looking at 3x minus 10y equals 14, and 3x minus 9y equals 15. So again, I'm going to just take the bottom one and subtract it. So 3 minus 3 is 0. Negative 10 plus 9, because it's a double negative, we get negative 1y. 14 minus 15, negative 1. So y equals, we can get rid of those negatives, y equals 1. Again, put that over here. Then take that 1, plug it back into the top one here. 3x minus 10 times 1 equals 14. So then we get 3x equals 24 as we add 10 to both sides, so x equals 8. 8 and 1. Okay, and that is how we solve for algebraically for systems with linear equations using the elimination method. Okay, take care, everybody.